Let us look at the chemical properties of carbon compounds. Combustion. All hydrocarbons burn in air or oxygen to form CO2 and H2O. The reactions are exothermic with the evolution of a large amount of heat. Examples are as given. If very limited air is supplied, then methane gives carbon black. Saturated hydrocarbon gives a clean flame or oxidizing flame, but when unsaturated carbon compounds burn, they give a yellow flame or reducing flame with lots of black carbon. At home, when gas or kerosene stove is used, a sufficient quantity of air is used, and hence we get clean blue flame. Fuels such as coal for engine and petroleum for vehicle having little quantity of sulfur and nitrogen. Their combustion results in the formation of sulfur and nitrogen, which is very dangerous for clean environment. Addition reaction. The reaction in which two molecules react to form a single product is known as addition reaction. This type of reaction occurs only in unsaturated compounds where there are double or triple bonds. Reactant adds to the carbon atoms of double bond and triple bond. Addition of hydrogen. Addition of hydrogen molecule to ethene gives corresponding ethane, that is saturated product. Unsaturated compound gets converted into saturated compound. Substitution reaction. Reactions where substitution of one or more atoms in a molecule for another atom takes place are called substitution reactions. CH4 plus Cl2 in presence of UV rays gives CH3Cl plus HCl. H replaced or substituted by Cl. CH3CH2I plus KOH gives CH3CH2OH plus Ki. I replaced or substituted by OH. Some important carbon compounds: ethanol and ethanoic acid. Ethanol is called ethyl alcohol or spirit. Ethanol has a formula C2H5OH and has a linear structure CH3CH2OH. The structural formula is given here. Let us look at the properties. Ethanol is a colorless liquid and has a pleasant odor. Boiling point is 78 degrees Celsius and freezing point is minus 114 degrees Celsius. It is combustible and burns with blue flame. Let us look at some reaction with ethyl alcohol. A. Action with sodium metal. When sodium comes in contact with ethyl alcohol, gives hydrogen gas. B. Action with PCl3. When ethyl alcohol reacts with PCl3, phosphorus trichloride, it forms ethyl chloride. Let us study in detail about ethanoic acid, commonly known as acetic acid. Ethanoic acid has the formula C2H4O2 and has a linear structure CH3COOH. Let us look at the properties. It is a weak acid, colorless, corrosive liquid and pungent smell at ordinary temperature. At below 290 degrees Celsius, it solidifies to an ice-like mass called glacial acetic acid. A. Reaction with halogens. When acetic acid reacts with chlorine, gives monochloroacetic acid. CH3COOH plus Cl2 gives CH2ClCOOH, monochloroacetic acid, plus HCl. CH2ClCOOH plus Cl2 gives CHCl2COOH dichloroacetic acid plus HCl. CHCl2COOH plus Cl2 gives CCl3COOH trichloroacetic acid plus HCl. B. Reaction with metals. When acetic acid reacts with sodium or zinc, gives sodium acetate with liberation of hydrogen gas. 2CH3COOH plus 2Na gives 2CH3COONA plus H2. C. Reactions with alcohol. When acetic acid reacts with ethyl alcohol in presence of anhydrous zinc chloride, ethyl acetate is formed. CH3COOH plus C2H5OH ethyl alcohol in presence of ZnCl2 gives CH3COOC2H5 ethyl acetate ester plus H2O. Let us study how the organic chemistry is related to soaps and detergents. Soaps are cleansing agents which are capable of reacting with water to dislodge the unwanted particles from cloth or skin. The molecules of soap are sodium or potassium salts of long-chain carboxylic acids. A soap molecule has a tadpole-shaped structure. At one end of soap molecule is a hydrocarbon chain that is insoluble in water but soluble in oil. At the other end of soap molecule as short polar carboxylate ion which is hydrophilic, that is water soluble but insoluble in oil. When soap is mixed with water, the solution becomes concentrated and causes foaming. The long, non-polar end of soap gravitates towards and surrounds the dirt and absorbs the dust in it. The short polar end with the carboxylate ion turns the water away from the dirt. The soap molecule thus helps in dissolving the dirt in water and we can wash our clothes clean. Let us look at the difference between toilet soap and laundry soap. High quality of fats and oils are used for raw material in toilet soaps. Cheaper quality of fats and oil are used in laundry soaps. In toilet soaps, expensive perfumes are added. In laundry soaps, cheaper perfumes are added. In toilet soaps, it is ensured that no free alkali content is there to prevent injuries to skin. In laundry soaps, no care is taken to see that no free alkali content is there to prevent injuries to skin.